Ladies and gentlemen, in this video we are going to have a bullet course of analytical geometry. So analytical geometry simply deals with straight line functions or linear functions. Linear functions is in the form of at x is equals to mx plus c, or y is equals to mx plus c, with constant c being your what? Your y-intercept. So y-intercept simply means the x value is equals to 0. Say now you have your Cartesian plane here. So you have your Cartesian plane here with a straight line function like this. And this is y is equals to x plus c. And here you have your x and here you have your y-axis. So this simply means now where your graph touches your y-axis, that is what we call an y-intercept. So your x value here is 0. So to find the constant c, you simply have to substitute where there's x with 0, then you're going to have your what? Your constant c as equals to the y value. Now, another formula or another part that we're going to discuss is the gradient. The gradient of the straight line is actually determined through m is equals to changing y divided by changing x. M is equals to y2. This simply means y2 minus y1 divided by x 2 minus x1. Now, say in this Cartesian plane and this graph, maybe this point is your coordinates. You have the coordinates of a here as 0 is to -2, and then say here you have your point b, and with the coordinates say this is 3 is to 1. Now here, to find your gradient, you simply going to substitute with you can pick any point and make this one maybe x1, or you might as well choose this one to be your x1. But if you choose this one to be your x1, this has to be your y1. If you choose this one to be your x1, then this is supposed to be your y1. Then this will be your x2, and this will be your y2. Now let's substitute to find our gradient. Our gradient is going to be y2 is going to be +1. +1 minus our y1 is going to be negative. Now, many people make mistakes with signs here. You have to open your bracket and put your -2 like this, because if you just put the value of 2, you're going to subtract +2 from 1, and here we need to subtract -2 from 1, since this negative sign is part of the formula for the slope or for the gradient. Now here underneath we're going to have x2, which is 3, and then x1, which is 0. Now the slope or the gradient of this graph is going to be what? 1 negative times negative is going to be positive. So 1 plus 2 is going to be 3, divided by 3 minus 0 is going to be 3. Then this simply means your slope is going to be 1. Now, another factor that has been discovered in analytical geometry is that actually the gradients of perpendicular line, say you have the gradient of AB, and which is perpendicular to the gradient of AD. Say your line AB is perpendicular to AD, then when the product of these gradients now is going to be -1. So you may utilize this formula to find the unknown coordinates if you come across questions where they require you to solve for unknown coordinates, where you can maybe substitute here with the formula changing y over changing x, then simply look for your unknown coordinates. Now, moving forward, we have the gradients of parallel lines. Gradients of parallel lines are equal. Gradients of parallel lines are equal. Actually, you can ask in the comment section if you are interested of how did they discover these things. If you want me to create a video where I explain how did they discover all these formulas, you can simply ask in the comment section, and then I'll make it a goal to upload a video explaining all that. Now here, discussing the parallel lines, the gradients of parallel lines. Say your AB is parallel to CD, line CD, then their gradients are going to be equal. Now, another formula that we have in analytical geometry is the midpoint formula. Say now we want the midpoint of AB. To find the midpoint, we are going to use the formula. Say we want the midpoint of AB. The coordinates is going to be x1 plus x2 divided by 2 is to y1 plus y2 divided by 2. These will be your coordinates of the midpoint. So to solve the midpoint of AB, we are going to have midpoint of AB, we are going to have x2 plus x1. See, this is the formula, x2 plus x1 plus x2, or x2 plus x1. So it's going to be 0 plus 0 plus 3, which is going to be 3 divided by 2. And then is 2, the y value is going to be what? The y value is going to be your y2 plus y1, or y1 plus y2. So it's negative 1, negative 2, negative 2 plus 1. Negative 2 plus 1 divided by 2. So the coordinates of the midpoint of A, B is going to be 3 divided by 2 is 2. Negative 2 plus 1 is going to be negative 1 all over 2. So these are going to be the coordinates of the midpoint of this line, or this graph, or this linear function. Now the next formula that we have in analytical geometry is the distance formula. Say now we want the distance from A to B, or from B to A. How many units do we have between A and B? Say we want the distance there. We will have the distance of AB is equals to the root. Even this one, you can still ask me in the comment section to explain where does this formula come from. Now we have here, we are going to have your x2 minus x1 close bracket squared plus y2 minus y1 squared. This is your distance formula. Then here you have it. This is actually if you want us, okay, now let's solve for the distance of these 2 points. Let's see how many units do we have between these two points. We are going to have the square root of what? The square root of x2. We said x2 is 3. x2 we said is 3. Subtract x1 we said is 0 squared plus y2 is 1, and then y1 is negative 2. y2 is 1, then y1 is negative 2. Again, most people or most learners make a mistake here with the signs. So I advise that whenever you are using your formulas in analytical geometry, please put your values in brackets so that you are not confusing. You are not going to fall into a trap of confusing the signs. Then here we're going to have 3 minus 0, which is 3 squared, which is going to be 9, plus open bracket, negative times negative is going to be positive, so 1 plus 2 is going to be 3 squared, and then we are going to have the square root of 9 plus 3 squared is going to be 9, which is equals to the square root of 8. This is the distance from A to b. So this is the bullet course of analytical geometry. Thanks.